So, now we will demonstrate how to measure the moment of inertia of a flywheel. So, as I have discussed in previous class that the working formula for this moment of inertia of a flywheel. So, this moment of inertia I equal to m 2 g h by omega square minus r square divided by 1 plus n 1 by n 2, and omega, the relation of omega with the n 2 is 4 pi n 2 by t. Okay. So, so this is the setup for this experiment to find out the moment of inertia of a flywheel. So, this is the basically this is the flywheel. So, I think yes, this is the flywheel, this is the flywheel. So, it has, you can see this, it has axis, this flywheel, this it rotate about this axis, right. So, this r in the working formula whatever we have seen, this r basically here this radius of this one is r in our working formula. So, that we have to measure this radius r, right. So, for measuring this radius r, just first we can measure this radius of this axis of the flywheel. So, why we are taking this radius of this axis of flywheel. So, that we will understand, because this place we are using for our experiment. So, using this thread with mass. So, as you know this how to measure the diameter or radius. So, we will use as usual these slide calipers. Okay. So, slide calipers we will use to measure this diameter or radius. So, you know already I have discussed about this slide calipers and how to use it, how to take reading, right. So, a slide caliper just we will use here this yes. First you have to take this whether is there any zero error, and then we will take this okay, reading for this place. So, here 2-3 reading you should take, and then we will do averaging of these 2-3 readings and find out the diameter or radius of this axis of the wheel. Okay. So, why we are taking diameter or radius at this place, that I will explain you. So, one parameter we have measured, that is diameter or radius. So, because it is this r is in working formula. Now, we have to measure basically other, what are the parameter we have to measure here. So, g is fine, g is basically this acceleration, gravitational acceleration. So, we have h, height, we have to measure height. Which height we have to measure, that I will explain, and how to measure radius of what, that I showed you, this radius of this axle that we are taking. So, that we have already measured, I showed you how to measure that one. Then in this formula omega is there, angular velocity. Okay. So, that we have to measure angular velocity of this flywheel we have to measure. So, this angular velocity omega is related like this. So, that means we have to measure basically n 2 and time t. So, what is n 2 and what is time t, that I will explain. So, if I measure n 2 and time t, then we can find out the omega. Okay. So, we have to measure practically, if we measure we have to measure n 1, what is n 1 I will explain. We have to measure n 2. Okay. If I measure n 2 as well as how much time it is taking for this n 2, if we measure, then we can get omega. okay, and then we have to also we have to know the mass. Okay. Either we have to measure or we have to we have to take weight and find out the mass. So, mass of what? So, here now I will explain. So, here in this experiment you know this basically working formula whatever we are using. So, that is derived based on the conservation of energy. So, basically potential energy is converted into the kinetic energy as well as frictional energy. So, basically what we have done. So, we have taken a mass with thread. So, I think I will just take out it first and then I will show you from the beginning. Okay. So, we have taken a mass. Okay. So, now if this mass is at different height, so this mass will have, so this mass will have it if it is at the ground, if it is at the ground, okay, if it is at the ground, so its potential energy is 0, because potential energy is mgh. Okay. M is the mass of this one, whatever we this mass is hanging from with this thread. So, this mass of this this weight. Okay. So, now when it is touching the floor, then h height we are taking, that one is 0 height. Okay. So, potential energy 0. Now, when I am taking up, okay, its height from the floor is increasing. So, its potential energy is increasing, mgh, h is increasing, potential energy is increasing. So, if I take at this height, so if I find out this what is the height of this this mass now. So, then I can tell what is the potential energy stored in this mass. Okay. So, now from this place, okay, what we will do, so starting from this place, if we just release this mass and it will move towards the floor, and when it will move towards the floor, then this wheel also will rotate. This wheel also will rotate. Okay. So, we have to do arrangement for that. So, basically the mass is moving towards the floor and simultaneously this wheel is moving, So, from where this wheel is getting energy to move, that is basically if we just do the arrangement in such a way that this potential energy decreasing, and that energy is basically spent for this movement, that is rotation of this wheel. So, basically this energy spent for this for the rotation of the wheel means for the kinetic energy of the wheel, angular kinetic energy of the wheel. Okay. As well as this mass, initially it was at static position, now also mass is moving, right. So, it has some velocity, say v, then also this mass will have this kinetic energy. So, that kinetic energy also it is coming from the potential energy, whatever the potential energy decreasing due to the mass movement towards the floor. So, basically the conversion, this is another nice experiment for showing that how this one energy is converted into the other energy. Here basically potential energy, how it is spent, how it is spent or how it is converted to the kinetic energy. So, from this experiment also one can understand. So, this omega is basically omega what in the formula whatever we show this, what is the angular velocity of this rotation, that we have to find out, and what is then n1 and n2. Okay. So, n1 is basically you see. So, this mass is hang from a thread. Okay. So, now this thread is at a particular, if I so just if we keep this way, here there is a hole, and if I put just to this pin kind of things. Okay. In this position if I keep, okay. So, you see it will just fall down, no, if I just leave it, but that means this edge of this weight, when it will just touch the floor, then it will be detached with the from this wheel. So, so basically this way we have made arrangement. So, at this position this kinetic potential energy of this mass is 0. Okay. So, so now what we are doing here, just you see at this position, this is a marker. Okay. This is the indicator marker. So, position of this wheel at this, under this condition, position of the wheel is you see we have marked with this yellow tape. Okay. So, this is the position of this wheel. Okay. Now, I am taking up the mass upwards. Okay. And I will count this. We are taking how many turns to take the mass up at a particular height. So, this you see this is 1 turn. So, then I will continue, this is 2 turn. Okay. Then this 3 turn, 4 turn, 5 turn, 6 turn, okay, 7 turn, 8 turn, then 9 turn, okay, then 10 turn. Okay. So, 10 turn. So, I have taken this height of the mass up, okay, and when we are taking up, then I have taken here 10 turns. That means, okay. So, now let me tell you. So, now mass is at this height. So, it has, if this height is h, so its potential energy is mgh, right. So, now what is the height that I have to measure? So, we will use the scale, it is the basically millimeter scale here, 900 millimeter. So, 90 centimeter. Okay. So, here I think this is the another 10. So, it is the meter scale. Okay. So, but its reading is I think it is labeled with the millimeter reading. So, so this other end is probably is 0, other end is probably it is yes, 10 is 0. So, initial position of the mass was it was just touching the floor. Okay. So, that is our 0 reading. So, that is there. Now, here I will take for this position what is the reading of the lower end of this mass. So, from here you can see it is I think 70 yeah. So, 1 centimeter, 2 centimeter, 3. So, it is the 67 centimeter, it is the 67 centimeter. Okay. So, this height is now 67 centimeter. So, that is basically h. Okay. So, its potential energy mgh. So, height is 67 centimeter. So, one can note down. Okay. So, for this height, at this height, so here turn is 10. Okay. So, now these 10 turns basically we are telling N1, because what is the N1? N1 is if I release it. So, this height will, this mass will go down, okay, towards floor. It will now its velocity 0. So, it will move down, its velocity will increase, okay, and this one also will rotate, because of this rotate. Okay. So, that is why we are telling this potential energy decreasing, and that energy is spent for the kinetic energy of the wheel rotation, as well as for the motion of this mass, as well as the friction, this dissipation of energy due to friction. Okay. So, that is because of this you see here when it is it turns, okay, ball bearing, this arrangement is there. So, this because of the friction at this place, inside ball bearing is there. So, there is a friction, it cannot be frictionless. Okay. So, due to the friction it will there will be energy spent. Okay. So, friction, if this friction that force or energy is F for each turn, energy spent for each turn is F. So, here during this, when it will touch the floor, then it will turn 10 times, right. It will just rotate 10 times. So, for each turn it is F, then for n1 turn, that is what we are telling, n1 turn. Okay. So, for each turn this energy dissipation will be there. So, that is n1f basically, in theory I told you. So, this is the meaning of n1. Okay. So, my position was 10 turn, it was there. Okay. So, this 10 n1 we are taking, this is the reading of this reading is 10. Okay. So, if I take 8 turn, if I take say 2 turn less, 1 and then another 8 turn, obviously now you see this height is different, right, height is different. Now, what is the height? Height will be that we can measure, this height we can measure. So, this height will be it is okay. I think this is 1, 2, 3, 4, 5, 6. It is around 54. It is around 54 centimeter, right. So, earlier for 10 turn it was 67. Now, for 8 turn it is 54. Okay. So, in our working formula there is a variable, one is h, another is r. So, r we cannot change, okay, and other variable is m. So, r we cannot change. We can change now these two parameter in our hand. One is we can repeat the experiment, just varying the height. Okay. So, we will do this experiment for 3 height. Okay. So, one for 10 turn and this height is 67, and another is 8 turn and height is 54. Okay. So, then you can take another height, okay, just take turn 6 and then what is the height you measure. For 3 height one can repeat the experiment and one can take the average of the result. Also we can vary the mass also. So, this 200 gram mass we have taken. So, this experiment can be done using the different mass. So, we have this mass of 50, it is 50 gram. So, we have 50 gram mass. So, you put 2, 3, 4 mass together, hang with this thread, and for different mass also. So, one can do this experiment, repeat the experiment for 2, 3 mass also. So, for 2, 3 height and or 2, 3 mass, one can do this experiment, repeat the experiment. So, repetition of the experiment is always better. Okay. So, here just basically I will show this, just show how to do for a particular mass and particular height. Okay. So, let me take this height. Okay. So, that means I have N1 equal to 8 turn, N1 equal to 8 turn. Okay. Now, I have to find out the N2. Okay. Mass I know, this is the 200 gram, and radius already we have measured, height also is, height also 54 we have measured, N1 also I know, this is the 8. Now, I have to find out N2 as per working formula. I have to find out N2 and time t. Okay. So, what is N2 and time t? Basically, when I will release it, so after 8 turn, so this mass will be detached from the system. Okay. So, no potential energies or this mass will not supply any energy to the system. Now, system, so when mass just will detach from this wheel, so it will have highest angular velocity, it will have highest angular velocity. Okay. So, when mass will detach, so this system will have the maximum kinetic energy. Now, so because of this kinetic energy, so this wheel will continue to rotate, and for this for the frictional force, because for each turn this frictional force is F as I told. Okay. For this frictional energy spent, that is F. Okay. So, this wheel starting from the highest angular velocity, so after some time it will just come to the, it will stop. Okay. It will come to the rest. Okay. So, it is coming to the rest, it means that this kinetic energy whatever this wheel was having, so that is spent for the friction. Okay. So, to come to the rest, so it will turn, how many times it will turn, it will rotate, and how much time it will take. So, that is why N2 and T. Okay. So, we will use stopwatch, Okay. So, yes, this stopwatch, we have start and stop button. I can, it is now 0 reset. Now, I can start, and it's you can see this, its resolution or least count is 0.01 second. Okay, 0.01 second. Okay. So, this so what I have to do, when just mass will detach, immediately I have to start the stopwatch, and when this wheel will come to the rest, and before coming to the rest, how many rotations that I have to count. So, that is N2, and immediately I have to stop the watch, and then I have to take the reading from this watch, that will be the T. Okay. So, let us do this one. So, yes. Okay. So, my watch is ready, I reset it to 0. Okay. So, this 0 reading. So, when it will just this mass will detach from the wheel, I will just start it, and when it will come to the rest, I will stop it. So, this one has to do very efficiently. So, I am so this the will count from here, because when it will be detached, so this position, this marker it will come at this position. So, that way we have placed it. So, yes, okay. So, if we start, stop, things are ready, I will start, then stop, then reset. Okay. So, I have to be familiar with this. So, this basically this is the so this I think start button, this the start button and this is the stop button, start button, stop button, and this the which one is reset button, that I have to see. Can you see please which one is start and stop button?
Start, stop, then reset.
Okay, start, stop, reset. Okay. So, basically yeah, I just learned this mechanism. So, stop, reset, start, stop, reset. Okay. So, so one has to be familiar with the instrument, you know, all the time. So, this is my starting point. Okay. Let us be ready. Let us be ready. Okay. So, marker I kept here. Okay. So, I just now just release it. Okay. So, it started, you see, rotation is started, rotation is started. So, it is then yeah, I am ready to start. Stopwatch, yes. So, I did mistake, but I have not yeah. So, one has to be efficient really. Okay. So, we have to start and now you see it stop. Okay. So, start and stop one has to really do very efficiently. So, but I was not able to do in very accurately. So, this is the way one has to practice and do the experiment. Okay. So, let me just repeat once more because it is not taking much time. So, all the time we can. So, this again just for another height you can do, another height we can do. So, for 10, so this way starting will be this. So, again I will take turn, I will take turn. Okay. So, this is the starting point. I think opposite way I have to take. So, this 1, 2, 3, 4, 5, 6, 7, 8, 9. So, for 10 turn I will take this time, for 10 turn I will take this time. Okay. For 10 turn. Okay. So, for the height already I have measured for 10 turn, that is 67 centimeter. Okay. So, again let me try with this yes. Okay. So, this hopefully I will do measurement very efficiently this time. So, I will yes. So, just I will release it now, I will release it now, yes. So, mass is going down, mass is going down, mass is going down, my stop is ready, stop. So, start. So, I have started 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16, stop. Okay. So, time is 25, time one can take reading, this time is 25.72. Okay. So, T is 25.72 and this what is the how many number of turns?
16 and half.
That is 16 and slightly more than that, that more or less you can see this is the just fractional, this will be half. So, how to find out this half, that I think one has to just take the circumference, and then what is this part of the this arc basically. Okay. So, so this length divided by this length of the circumference. So, that will be the fraction. So, it is 16 point whatever the fraction. So, that will be the reading. Okay. So, N 2 will be 16 point, more or less you can take is half. So, you have T 25.72 and N 2 is 16.5 and N 1 is 10, height is 56 centimeter. So, all parameters are now known, whatever in working formula you need, mass is 200 gram. So, one can calculate. So, now one can repeat this experiment for another height. Okay. So, 3 sets of reading you will get. Okay. Or if you want this for each height, you can vary the mass. Okay, 200 gram is there. So, you take another mass, say 300 gram, and repeat again the experiment for this mass. Okay. So, that way you take a few sets of data, and then in next class I will discuss how to analyze the data, find out this moment of inertia of this flywheel, as well as this some other aspect also we will discuss. Okay. So, error calculation, etc. So, I think this I will stop today. Thank you very much.